in the last video, we saw the adjacency list representation of graph in C++, and the same graph we will be implementing in Java in this video. So this particular graph has 6 nodes, that is 0, 1, 2, 3, 4, and 5. And it has 7 number of edges, that is 1, 2, 3, 4, 5, 6, and 7. Okay, so there are 7 edges and 6 nodes in this particular graph. So we'll start with declaring a static class of graph in Java. So I'll have static class graph. And this graph should contain, so if you remember that in C++ we used a vector int graph kind of representation to basically represent our adjacency list. The same thing we'll use here as well, but then instead of vector int, we have array list of int. That is because the alternative to vector int in Java is an array list. So how you have STL containers in C++, the same way you have collection framework in Java. So first let me have a variable called total nodes. So this total node should indicate how many nodes does this graph contain. And then we should have a list of array list. Okay, so this list would be containing integer elements, and let us call this as graph. Okay. So list of integer graph. So here you can directly instantiate via array list, but then I will be using the list interface for representing this array list. Okay, so list integer graph, and this is going to be an array of graph. So we will be having these square brackets at the end. All right, so let me declare a constructor for this. So I'll have graph int total nodes. Okay, and we'll have this dot total nodes is equal to total nodes. And we will be initializing our graph variable, that is an array of array list, is equal to, so graph is equal to new array list. So we'll have array list, we'll have new array list of total nodes. Okay, so new array list of total nodes. So this would basically declare an array of array list. Okay, so let me remove this particular comment because it's not looking good there. All right, so we have this particular graph over here, that is static class graph. We have a variable called total nodes that indicates how many nodes does this graph has. So in this particular graph, it should be containing the value 6. Okay, and then we have a list of graphs. So this is analogous to vector int graph. Okay, so vector int graph. Okay, and this particular v variable, that is how many elements are there in this particular array. So this we will be initializing inside the constructor here. We will be initializing graph is equal to new array list of total nodes. So total nodes is equal to is analogous to v over here. All right, so this is the representation of adjacency list in Java. So now what we'll do is we'll just create an instance of the graph class. So we have graph is equal to new graph. And inside our graph, we have 6 nodes, right? So we have 6 nodes over here. That's the reason why I have put 6 over here. Okay, so I can also declare a variable called public static final int total nodes is equal to 6. And I'll use this total nodes variable inside this particular constructor over here. And now we need a function that can add an edge to the adjacency list. So for that, I'll declare a new function called void add edge. Okay, so for add edge, we need the information between which two vertices do we need to add the edge. So we'll have source and int destination. Okay, so in this graph, we have undirected edges. That means if you have an edge between 3 and 5, right? So you can move from 3 to 5. The movement from 5 to 3 is also possible. So that's the undirected edge. So how do we add an undirected edge? So what I'll do is I will just do graph of source dot add. Okay, so graph of source dot add destination and graph of destination dot add source. Okay, so this would basically add an undirected edge to the graph. Had it been a directed edge, you do not need to put the second statement over there. But then since we have the undirected edges in our graph, we will be keeping this particular statement over here. Okay, so this function should add an edge to your graph. Okay, so one more thing that we missed in the constructor is we need to initialize all the elements of the graph. That is, so the moment you invoke this particular constructor over here, so it will basically do something like this. So you'll have the array of nodes that would be created. Okay, so this would be something like this. So you have 1, 2, 3, 4, and then 5. So this thing would be created But then we see here that the memory to the array list has not been allocated till now. Okay, so in Java, you have to explicitly allocate memory using the new keyword. So for allocating the memory for the array list, what I'll do is I'll just run a for loop over all the elements for int I, for int node is equal to 0, node less than total nodes, and node plus plus. What I'll do is I'll do graph of node is equal to new array list of this particular thing. We'll initialize each of these array elements with an empty array list. Okay, so it will look something like this now. Okay, after this particular for loop, it will look something like this. That means all the elements would now contain an empty array list. Okay, so now when you try to do an add, okay, so when you try to do an add operation to this particular array list, it will be appending the elements into this array list. However, if you hadn't done this particular initialization, this list would not be present. And if you try to insert an element into an array list that doesn't exist, that hasn't been even allocated memory, then you get a null pointer exception. Okay, so that's the reason why this particular statement is important over here, right? So yeah, so we are done with the add edge function as well. So what I'll do is I'll just do a graph dot add edge, and let me add this particular edge, so 0 1. So I'll have 0 and 1. Okay, so then we have between 1 and 2, so graph dot add edge between 1 and 2. Then we have between 1 and 5, graph dot add edge between 1 and 5. Then we have between 0 and 5, graph dot add edge 0 and 5. Then we have between 3 and 5, so graph dot add edge 3 and 5. Then we have between 3 and 4, graph dot add edge 3 and 4. Then we have it in 2 and 4, graph dot add edge between 2 and 4. Okay, so how many edges did we have? So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So we have total 7 edges in our graph added. Okay, so now we need to have a function that can print this particular graph. Okay, so that basically prints which are the nodes that are neighbor to a given vertex. If let's consider that source node is 3. So for this 3, which are the nodes adjacent to 3? Then it should be containing the vertices that are adjacent to 3. So it will be containing 4, 5. Okay, so or 5, 4. So the order doesn't matter over here. All right, so let us implement the print graph function for this graph. So we'll have void print graph. Okay, so this print graph function, what it'll do is it will go through all the vertices, it will go through all the nodes, and it will print the adjacency list that is being populated over here. So after all these add edge functions are executed, we'll have all these empty array lists that we initialized. These will be populated with vertices values. Okay, and we need to print these vertices values that are contained in the neighbor lists. Okay, so this 0 will contain an array list, 1 will contain an array list of neighbors, 2 will contain an array list of neighbors. So our job is basically to print the neighbor list, that is an array list that is associated with each of these vertices. Okay, and just to show that there is an edge between 0 and maybe what do we have? So there's an edge between 0 and 1, there's an edge between 0 and 5. So that should be our print graph function. So what we'll do is we'll go through all the elements. So let me have a simple system.out.println statement. So just indicating that the adjacency list representation of graph is okay. And let me run a for loop over all the nodes. So int source is equal to 0, source less than total nodes, and source plus plus. So this for loop, what it does, it goes through each of these nodes. That is, first it'll go through 0, then it goes through 1, goes through 2, goes through 3. Okay, so like that it'll go through each of these vertices, treating each of these vertices as source. Okay, and it'll just see which are the destinations that this source vertex is connected to. Okay, so in this case, let's consider 0 to be the source. So the destination could be 1, it could be 5, because these 1 and 5 are connected to 0 directly. Okay, So what I'll do is, so inside this for loop, I'll have another for loop which goes through all the elements in the array list of source. Okay, so I'll have something like int destination in graph of source. Okay, so first this graph of source variable will contain graph of 0. So graph of 0 is an array list of neighbors of 0. Then it will have source is equal to 1. So graph of 1 would be the list corresponding to vertex 1. That would be the neighbor list of 1. Source of 2 would be containing the neighbor list of 2. So that would be containing 1 and 4, and so on and so forth. It will be keep on going. Okay, so destination value would be all the neighbors associated with the given source. Okay, so what I'll do is I'll simply print system.out.println. Okay, so there is an edge between I'll print source plus and destination. Okay, so I will print something like this. Or maybe what we can do is we can print in a better manner. What I'll do is system.out.print. Okay, and here I'll just print the destination with a comma sign over here. Okay, and on the top what I'll print is system.out.println number of neighbors for source are graph of source dot size. Okay, and we will be then printing the list of neighbors. System.out.println neighbors of source are, and let it be a print statement rather than println statement. Neighbor of source are, and it will be printing all the vertices that are neighbors of the source vertex, and let us leave a line after all the neighbors are printed. Okay, so we'll have system.out.println, and then we have another system.out.println statement after we print all the neighbors associated with all the vertices. Okay, so this is our print graph function. Okay, so it will basically print how many neighbors does a given source vertex has, and it will also print what are the neighbors associated with that source vertex. Okay, so let me just give a call to graph.printgraph in the main function. Okay, and let me just try to run this. Okay, let's see the output. What do we get over here? Okay, so here you can see that adjacency list representation of graph is, the number of neighbors of 0 are 2. So we'll just see here. So number of neighbors of 0 are 2. So that is 1 and 5. So here you can see that neighbors of 0 are 1 and 5. So number of neighbors of 1 are 3, and neighbors of 1 are 0, 2 and 5. So number of neighbors of 1 are 1, 2 and 3, and that is 0, 2 and 5. So the order doesn't matter over here. You just need to check whether the neighbors that are printed are correct or not. Okay, so next we'll check for 2. So we have 1 and 4 for 2. So for 2 here we have 1, and then we have 4, and then for 3 we have 5 and 4. For 3 we have 5 and 4. For 4 we have 3 and 2. So for 4 we have 3 and 2, and for 5 we have 1, 0 and 3. So for 5 we have 1, 0 and 3. Okay, so this is how we represent adjacency list in Java. Okay, and let me show you one more thing, that is had we not included this particular statement over here, what error do we get here? Okay, so let me run this program. So I've commented this particular for loop which basically allocates memory to each of the array elements. Okay, so here you can see that we get an error called null pointer exception, and it says that cannot invoke add method because this .graph source is null. This is because if we do not allocate memory for the array list using new keyword, then this add statement is basically trying to add an element to an array list that doesn't exist, that is null basically, and that's the reason why we are getting this null pointer exception over here. Okay, so let me uncomment it back because this is necessary part of the code. Okay, and this should constitute the adjacency list representation of graph in Java.